Okay, so some of you are here. Wonderful. You made it, survived. But if you're not here, that's okay. If you're on Twitch, hopefully you're watching and participating in the lecture. Get on the chat box. Let us know you're here. See, somebody's here talking about the weather already. It is cold. Okay, so make sure you send me your Pachakacha analysis. I need those today. I will get them graded. Get your presentations graded and start putting some grades in Moodle. Unless you don't have any grades in Moodle yet. I will try to get to that this week so that you know how you're doing in this class. Any questions about what I need from that analysis? Yeah.
How long does that be?
3 paragraphs. 1 talking about your preparation, 1 analyzing your presentation, 1 about Pachakacha itself. Do you think this was a worthwhile thing for us to do as a class? Okay, so I do want to demonstrate some of the awesomeness that we had turned in. They were all pretty good, the ones I glanced through. I haven't made a detailed analysis of them, but the marble machines were looking really cool. Let's just see a couple of them, see if we have any questions about how people did stuff. See if I can load them up. Here is one of the marble machines. Let's get that game looking big again. Look at those marbles go. Spinning things, water. Somebody had a palm tree. These were nice. I think you're really seeing how the physics go together to make some of these animations happen. These balls are glowing. They've got lights on them. And then they automatically fly up to the top again. Okay, so let's see another 1 or 2. Open project. Let me find the scene here. Get that out. Marble machine. People seem to like these cogs and wheels spinning around. They do nice things. And this person has 3 cameras, 1 watching the scene, 1 just watching the randomizer, and 1 watching an individual ball, waiting for its time. There we go. And you're starting to add small little scripts to objects. That's our goal today, is to make sure we understand how to put scripts onto objects. How to create a scene like this just with a script and get familiar and comfortable with the C# idea. We'll start seeing the cool, awesome things you can do with scripts here soon, but amazing marble machines. I was really impressed with your marble machines. Any questions to wrap up your marble machines? Things that didn't work out well, things that were still struggles? Okay, so let's talk about mazes. This is what you should be working on now. Trying to make a maze show up automatically in Unity. For example, here's an algorithm that generates a maze using the recursive backtracker algorithm. somehow piecing it together, using some data structures, creating a maze as it goes. How many of you have made progress trying to get a maze to work in Unity? Some of you. Okay, cool. What kind of algorithms have you chosen to implement? Which ones are you doing? That one?
The backtracker.
The first one?
I did.
The which one?
The backtracker looks the nicest. The other ones are just kind of.
Yeah, this one looks more like what you're used to with a maze. Yeah. This one, okay. Really fast. Generate the maze. There's no backtracking. There's no other stuff. Did anybody pick anything else besides?
I'm working on the prims.
You're working on which one?
Prims algorithm.
Prims algorithm. Okay, Kruskal's and Prims. They're ways to make the minimum spanning tree. You might hear about that in a combinatorics class, or maybe discrete. I'm not sure where it might be taught here, but saying all these nodes are connected. We want each one of them to be connected to one other square. That will give us a tree that spans the whole thing and gives us that perfect. Any others that you looked at? Okay, what kind of struggles are you having? Let's see what the stream is saying. Nothing. Okay, what kind of struggles are you having?
I have an issue where I try to find a game object and it's saying it's not a maze cell, basically. It might be really specific to my problems, but I'm having issues finding game objects, I guess.
Okay, so there's ways to say, hey, whole big game, go find this object based on its name.
Yeah, and that's what I'm using, but it's just like throwing me an error saying it's not what I think it is. So I guess I just need to.
Okay, once you get it, you want to make sure you cast it to the appropriate object type that you want. So you might be getting it, but then it says, here's what the type is. Make sure when you say get component or other kind of finds, you have to cast the result as what you expect. Otherwise, it won't fit in the right boxes for the references. That might be the problem. Other things you're encountering. Everything going swimmingly? You've got mazes? No, I don't think so. So what is going on? What's working, what isn't? What kind of little things are you noticing that's different between C# and Java?
Capitalize in C#.
Capitalization for all the methods. Yes, you look at something and you're like, that's an object. No, it's not. It's a method, and it's a method that just does normal things. So get it out of your head that capitalized things are always objects. That could be an object, it could be a method of an object. Variables are lowercase, mostly. Other things. Yeah.
I really enjoyed type inference. VAR is really cool.
VAR?
Yeah.
Yes. It can just pick up on stuff. You don't have to do casting sometimes if you don't need to do casting. And you're like, oh, I think this thing can do what it wants to. It has a transform. Maybe VARs are enough for you. Anything else? Anybody tried to use arrays? What's different about arrays?
There are multi-dimensional as well as arrays within arrays. I don't really understand what the difference is, though.
So the way that C# wants you to do it is with a bunch of commas inside one set of square brackets. Is that what you're talking about? Yeah. So instead of Java, where it's all references to references to references to get you back to a single one-dimensional array, the syntax is very slightly different to make two-dimensional arrays, three-dimensional arrays, four-dimensional arrays. You just put commas inside the square brackets instead of out.
The jagged arrays are pretty cool too. So you can have a multi-dimensional array with different numbers of items in each dimension.
Yes. Yes, you could do that in Java.
Can you?
Yes, because it's just references to other
so
references
just-
of things. Yeah, but it is possible also in C+ or C# to do that. Yeah. Okay, so I worked through the recursive division algorithm. And I'll walk you through that today to show you what I did to make this one work. And maybe that'll bring up some things you have questions about. Maybe that'll make some things make more sense as you're seeing me implement this algorithm. So just to show you a picture of what it does, it runs through and recursively divides up the space. I have a huge chunk, pick a line, slice it up, pick a line, slice it up, pick a box, slice it up, recursively working through. Because a maze is, again, a tree. Recursion goes along with trees so well. And it doesn't just say, here's a box, let's split it some way. The idea it says is, let's split it on the long piece. So again, let's run this. You'll notice that when it has a big box like this, it's going to divide it this way. It always says which way is longer. Let's divide it like that instead of always getting us huge streaks. It tries to have that small little idea to it. So I'll work through this implementation today, and as I do, ask a bunch of questions. Hey, why did you do that? How did that work? So that you can see me implementing one of these algorithms so that you can get comfortable coding one yourself. Seeing all the small little changes I had to make and all the different ways that Unity lets us put those objects together. Does that make sense? Okay, let's do that. I have one finished. One is already in the oven in terms of cooking show technology. But I do have one that I will create as we go, and hopefully if that one doesn't turn out well, I can pull the other one out of the oven and we can have a nice Unity baked casserole at the end. So let's make this happen. New project. Recursive maze. There's my game. Let's leave that in the back. I need some walls. I need to make a wall happen. So like before, create an empty child. Let's call it a wall. Let's make a cube. Scale. Let's make it small.